Okay, we're going to get started. Welcome everybody to Technology Challenge, Battery versus Fuel Cell Electric Solutions. I'm Dan Raudebaugh, the Executive Director of CTE. This is the second day of our webinar series, and we are looking forward to a lively debate between a couple of folks from CTE and a couple of people from industry to talk about battery electric versus fuel cell electric and how they compare to each other and how they compare to incumbent diesel and CNG technologies. But before we get started, this session is sponsored by New Flyer. New Flyer is the perfect sponsor for this section because they have both a battery electric and a fuel cell electric bus available in the North American market. So who better to speak to both technologies than Chris Stoddart, president of New Flyer. Chris, take it away.
Thank you for the introduction, and thanks so much to the CTE team for welcoming me today. I'm pleased to be here, and if you'd asked me to speak 8 months ago, our conversation today would have focused only on zero-emission bus technology, the challenges of scaling adoption, and the benefits of reduced traffic congestion, cleaner air, and more livable cities. So much has happened in that time, and today so much is still happening, not just for mobility and the restoration of public transit, but as humans, we're experiencing 5 simultaneous global crises, including a global health pandemic, a very large civil rights movement, an economic recession, significant political unrest, and the harsh realities of climate change. Not to mention a complete disruption of work and personal life. As an industry, we've watched ridership and farebox revenue drop overnight, funding uncertainties become real, and public confidence shaken. But it's not all bad. During this time, we've also learned a few really valuable lessons. First, we relearned how important transit is to our communities. Throughout this crisis, public transit has served essential workers, healthcare professionals, and citizens in urban areas who do not own cars. In some cases, bus ridership rebounded and even surpassed that of rail, such as in New York, where bus ridership leapt ahead of subway ridership for the first time in 50 years. Second, our entire industry came together quickly and powerfully to develop and implement measures to support public transit recovery. As part of this, we challenged ourselves to facilitate safer ridership and provide processes and products that address public health concerns. As we continue to adapt to new data that becomes available, our priority remains supporting the recovery of transit, as well as the restoration of confidence in a safe transit experience. And finally, we know that resiliency is a crucial consideration in any roadmap for the future. Smart mobility solutions must include both technological and business innovations that help systems absorb public health and financial shocks. Government and industry investment and support will be needed to make this happen. That said, I'm not here to talk about COVID, and I'm certain no one wants to hear the word unprecedented again. Instead, I'm going to talk about the power of electric mobility, both battery and fuel cell propulsion, and the critical support needed to enable a zero-emission future. Today, New Flyer looks different than it did just a few years ago. We're now part of the NFI Group family, one of the world's largest bus manufacturers, and about 1 month ago, NFI announced a combination of the New Flyer and MCI businesses. New Flyer's zero-emission offerings have been fully introduced on our entire portfolio of products. MCI has now introduced battery electric coaches on both their D and J models. Alexander Dennis now has electric variants of their double-deck buses for the North American market. And the Raudebaugh team is aggressively launching their battery electric Equus medium-duty bus with a running prototype by the end of this year. The NFI family proudly offers the widest range of buses and coaches on the market. This is in addition to an actively growing infrastructure business, which I'll expand on in just a minute. All our transit manufacturing facilities are now capable of producing zero-emission buses. We've invested in training our people to package batteries, install fuel cells, work with high voltage, commission and charge zero-emission buses. These learnings extend to our network of field technicians and trainers who support our customer base. We're proud to now serve transit agencies with complete mobility solutions. Our buses currently support over 50 zero-emission programs across North America. Our fuel cell journey began in 1993 with prototype technology, followed by a 20-bus evaluation program for the 2010 Olympics, which helped lead to our current generation platform. In 2018, we delivered the first 60-foot zero-emission fuel cell bus in North America, and in 2019 we reached 350 miles of range during a 40-foot hydrogen bus test demonstration. Today, our fuel cell buses using Ballard fuel cells have been deployed with some of the most notable zero-emission leaders, including Sunline, Orange County, AC Transit, and soon, Champaign-Urbana too. Despite the candid debates we'll hear on battery versus fuel cell, know that these technologies are exceptionally complementary, with the vast majority of the vehicle architecture remaining identical, really just trading less batteries for a fuel cell and hydrogen tanks. And each can be a one-to-one replacement in zero-emission fleets. When we look ahead to 2021, it's remarkable to see the appetite for zero-emission has not waned. For New Flyer transit market share, both technologies, battery and fuel cell, appear to be doubling in sales year over year, which combined should put us approximately 20% zero-emission volume. The ratio of fuel cells is slightly north of 10% of our zero-emission sales, which is very encouraging. At a high level, both fuel cell and battery technology are on similar trajectories of advancement rate in both reliability, performance, weight, cost, and energy density. The primary difference is still range and cost. Our in-service range for battery electric buses can go between 180 and 230 miles, where our fuel cell buses are closer to a range of 300 to 350 plus miles. In the next 24 to 36 months, I see that gap closing to where battery electric buses will approach the 280 to 300 miles. I think it's too early to predict where the capital cost delta will end up between the two technologies, but fuel cells remain a bit more expensive right now. However, I continue to be encouraged by the economics of both technologies with current state technology, and the future technology with volume increases, will continue to make the business case even more favorable. We've continued to innovate and to invest in education, workforce development, and advocacy to help keep zero-emission bus and infrastructure adoption moving forward. In fact, our own team managed to complete more than 60,000 hours of training this year, even through the pandemic. And speaking of infrastructure, this is the most critical part of zero-emission bus adoption and the most influential factor of success behind electric bus deployments. For us, it's a growing business and a cause for optimism, which is nice to experience these days. I know I'm preaching to the choir, but when we consider infrastructure, the importance of managing complexities and planning to get it done right and on time can't possibly be overstated. And what's remarkable is how our industry has come together to share best practices in this space. If you'd asked me 5 years ago if New Flyer would be in the infrastructure game, I would have likely said no. But quickly we've realized electric bus deployment relies extensively on infrastructure, and the design, commissioning, and readiness of infrastructure cannot be underestimated. So today, we proudly offer New Flyer Infrastructure Solutions as a full suite service. This team, which has grown since announcing it in early 2019, is dedicated to providing safe, reliable services for smart, sustainable mobility projects, and today has installed just over 150 chargers across America. Energy optimization, design, and installation of wayside and depot chargers, coordinating UL certifications, site visits, on-grid bus testing and commissioning, providing engineering services, financial projections, are just some of the tasks this team takes on. Supporting zero-emission operation takes the quiet power of analytics, and for New Flyer, this includes the New Flyer Connect over-the-air technology to harness data for better efficiency, operation, and performance. 20 years ago, I bet you'd never imagine you could manage your bus fleet from a mobile phone, but here we are. This ability has proven especially critical in understanding bus performance and energy usage through extreme climates and conditions, which I'm proud to say our buses have steadily performed through. The lessons we've learned have hit home, specifically with respect to zero-emission adoption. Implementing renewable energy as a source of fuel, developing interoperability, and preparing for redundancy and emergency response are key elements of infrastructure deployment. So is workforce development. And that's why we built the Vehicle Innovation Center, which is the only bus and coach innovation lab of its kind in North America, dedicated to advancing technology and providing critical workforce development to an industry facing significant technological change. I'm also proud to share that to date, we've welcomed just under 2,000 people through the doors of the VIC for critical electric bus programming. In addition, we've worked hard to collaborate with industry leaders on both sides of the border to ensure development of charging standards to foster interoperability and to best steward funds invested in zero-emission adoption. Today, our buses are interoperable with most competitors' e-buses, and multiple chargers including ABB, Siemens, ChargePoint, and Heliox, to name a few. When you think about the impact of public transit, more specifically zero emission, we're really working alongside stakeholders to improve quality of life, accessibility, healthcare cost, inclusion, convenience, community. This can all be supported by advances in public transit. And the need for greater mobility isn't going away, specifically in urban settings when densification continues to proliferate and the emergence of megacities is becoming commonplace. We're amidst one of the most challenging years of anyone's generation, but looking ahead to when we get through this chapter, and we will, we know mobility will continue to take its place as the heartbeat of communities. COVID has taught us something, and let's learn from it. All of us were forced overnight to embrace technology available today, video conferencing, remote engineering, electronic document signing, etc., and with much success. So when I consider what this means for reimagining mobility experience, this injects a new approach to the art of the possible. There's a better ridership experience, clean, quiet, connected mobility that is safer for all. And I hope people will be more open-minded to what can be done now. The technology is here. Together, let's ensure our industry capitalizes on that mindset.
Well, thank you, Chris. That's a great introduction and a great lead into our debate today on technology challenge, battery versus fuel cell electric buses. Again, I'm Dan Raudebaugh. I'm the Executive Director of CTE. And before we get started on our debate, I would like to tell you a little bit about CTE and our role with both battery electric and fuel cell electric buses. For those of you that are new that weren't with us yesterday, CTE is a 501c3 nonprofit. We're based in Atlanta, Georgia. We have offices in St. Paul, Minnesota, Berkeley, and LA, California. Been around since 1993. And we have endeavored for the past 27 years to try to move advanced transportation technologies into the marketplace. In the 90s, we focused a lot on hybrid vehicles, for a lot of them for military applications and commercial applications. In the early 2000s, we did a lot of CNG work, but since about 2005, CTE has really focused on zero-emission technologies. And what are those technologies? Well, the battery electric and fuel cell electric are the two qualifying technologies for zero tailpipe emissions. So the debate today is both technologies start fighting for market space. We as an organization think there's room for both. In fact, we think that both will be successful in the transit bus marketplace, in the university bus marketplace, airport marketplace, school bus marketplace, maybe a little bit more battery electric, but I wouldn't give up on fuel cell for that application either. So let's talk a little bit about our experience with fuel cells and batteries and how we see them working together. This is a map I'm very, very proud of. CTE is I think #1 in North America, probably #1 in the world in providing technical assistance to transit agencies that want to deploy zero-emission buses. You can see the blue dots on this map are the fuel cell electric bus projects that we've worked on or been involved with around the country. The green dots are on the map or our battery electric bus projects. Often when we work with fuel cells, people are thinking we're very fuel cell focused, but you can see we do a lot more battery electric than we do fuel cell. But as a percentage of total deployments, I think we're doing about 1/3 of the battery electric bus deployments in the US, and we're involved with probably 2/3 or a little more of the fuel cell bus deployments in the US. As the market in North America and in the US in particular, battery electric is got the majority of the market. We will see how that plays out as the market develops. Next slide. This is a slide I showed at the Fuel Cell Bus Conference in LA 2 years ago, and it got a lot of attention. And I think it really speaks to how CTE views fuel cell and battery electric buses in this market. On the y-axis, you've got effort and cost going up, and on the x-axis, you've got fleet size going up. And what we see with battery electrics, if you're doing 5 buses, cost-wise, there's really no comparison. Battery electric, you put in your 5 battery electric buses, which are less expensive than fuel cell buses, and you put a charger for each bus, and it's an easy effort for 5 buses. For 5 fuel cell buses, you're looking at a couple $1 million hydrogen fueling station to fuel 5 buses. When you amortize the cost of that fueling station over a small fleet, 5 buses, it becomes prohibitively expensive when compared to battery electric for a 5-bus deployment. But here's the secret. Fuel cell buses, as you increase in numbers, the cost per bus of the infrastructure actually goes down, because if I put in hydrogen infrastructure to fuel 5 buses, I can put it in incrementally large enough to do 50 or 100 without spending too much more money. So every time I add a fuel cell bus to a fueling station that will fuel 50 or 75 buses, I don't pay additional cost for that infrastructure. I only pay additional cost for the fuel and the bus. Battery electric buses is not quite as simple as just adding a charger per bus as you grow, because ultimately if you have a bus yard in an urban area, let's say there's 150 buses parked and fueled there at night, you are going to have to increase, or you're going to have to expand the infrastructure necessary to support that load. So for 5 buses, the transformer switchgear that you have may be sufficient. It may be sufficient up to 20 or 25 buses, but at some point, you're going to need to increase capacity at the station, and that can be quite costly, especially if you're going to do 150 to 200 buses. You're basically putting in a substation in an urban area, and the cost of that actually goes up per bus on the price of the bus. Now, it's interesting that we have these lines crossing over, because at some point in that evolution, the cost will be equal. We put it in the middle because we work with both technologies. I don't have a crystal ball to see exactly where these lines will cross over. I promise you, if you talk to Jack Allen at Proterra, or if you talk to Elon Musk, they've got the battery electric, the fuel cell bus not crossing in price to the battery electric to the very, very end of the fleet size chart, or if at all. But if you talk to Ballard, who we work with a lot, Hydrogenics, or Toyota, for example, they would probably have this fuel cell bus line crossing over way before midway in this chart. So nobody really knows the answer, and we obviously think there's going to be both, and only time will tell as it goes. So I think that's a great lead into our debate today. We want this debate to be lively. We want it to be fun. We certainly do not want to take shots at each other, but I think it's important to realize that this market is here for zero-emission buses, that these two technologies will be fighting for market space. And I think it's a good idea for us to go ahead and say, yes, they are different. They have certain advantages. They have certain disadvantages. Let's talk about what they are. Let's be open about it and honest about it, because in our opinion, they're clearly superior technologies to the diesel and CNG technologies that they're replacing. So let's talk about how they compare to each other. So without further ado, I am going to jump in and introduce our speakers today, our teams. We have 2 teams. Have somebody from CT on each team, and then we have a couple of industry folks. So I'm going to start with the fuel cell team. Karl Gnadt is going to be our industry representative on the fuel cell team. Karl is the managing director at MTD in Champaign-Urbana, Illinois. Karl oversees the $61.7 million operating and capital budget, has 375 employees working for him, and of course, as managing director, oversees all aspects of the operation. I think it's important to point out that Karl is deploying fuel cell buses. He's deployed, he's grown his hybrid bus fleet to 92% of the fleet size, and he's received $17.3 million in federal grants to support a $275+ million public-private expansion of their MTD's Illinois terminal in downtown Champaign. So Karl's got some good experience with fuel cell buses. He's obviously operated hybrid buses, diesel buses, and has a good, we think, a good perspective on why go with hydrogen. Helping him from the CTE team, we have Jaimie Levin. I think a lot of folks that are listening here will know Jaimie. Jaimie's been around for some time. He got a planning degree from Cal Berkeley in 1956. Yes, 1956. He's 73 years old, believe it or not. Jaimie don't look a day over 72 in my book. But Jaimie has been with, before he was with CTE, he spent 7 years with CTE. Before that, he was with AC Transit, where he managed their fuel cell bus deployment. He was there for 14 years, and I would say, and I've said this often, I think AC Transit's fuel cell bus deployment is the #1 example in the world of how to deploy fuel cell buses. So Jaimie will be helping Karl today in our debate. We will be facing off against a team from industry. We have Leah Dwyer. Leah is the head of eBus infrastructure at ChargePoint. She's been at ChargePoint, I think, for about 3 or 4 years. Before that, she was with Siemens for 7 years, and Leah was on our debate stage last year. We had a very lively debate with her and Chris Kretz from Air Products. She's back again and looking forward to taking on Jaimie. I think everybody is. And I will, one more note about Leah, so we're going to be as nice as we can to Leah. Leah's on CTE's board, and she's been on the board for 1.5 years. Helping Leah is Jason Hanlin. Jason is our Director of Technology Development, and he's a Senior Project Manager at CTE. Jason, prior to that, worked at Delta, and I think he's been with CTE something like, Jason, 15 or 16 years. He leads our prototype development effort. Jason's got good experience with both fuel cell buses and battery electric. Of note, Proterra's first bus, believe it or not, was a fuel cell bus. Jason managed the build of that. He's worked in many different vehicle types. He's worked, as I said, both on battery electric and fuel cell electric. He's got a degree a degree in mechanical engineering from the University of Tennessee. He's also got a degree, master's in mechanical engineering from my alma mater, Georgia Tech. So Jason's got good experience, and I would like to say before we get going, if you guys know Jaimie, I tell people all the time Jaimie's fuel cell bias, and Jaimie's been doing this a long time, and he's got a lot of passion. So what we try to do as an organization is, instead of trying to convince Jaimie that battery electric buses are the way to go, we try to balance that out as best we can. And so we present with you today Jason, who has worked with both and I think has maybe a little bit more pragmatic approach. So I'm looking forward to those two taking each other on as well. So without further ado, we are going to get started. I've got a list of questions, and our format is we're going to switch between teams. I'll ask a question to the hydrogen team first. The hydrogen team will have 2 minutes to respond. Then the battery team will have 2 minutes to rebut or to add to that argument. And then the hydrogen team will have a minute to wrap up. I'll then switch roles as we move. I think we're going to move everybody to the screen here. I'm going to ask the first question to the hydrogen team. The question is, why make the change from fossil fuel technology to begin with? Why are we even looking at this? Hydrogen team, who's going to take that one on?
I'll take that, Dan. Thanks. So, you know, we're all on the same boat here. We're living in a fossil fuel economy. It's very heavily subsidized, but unfortunately, fossil fuels are not renewable. And so that boat that we're in is headed for an iceberg, and we need to shift the direction. And both battery electric and fuel cell electric can accomplish that, but it will take money and it will take resources. Moving the Titanic is not an easy task, and it will take a lot of money and a lot of resources to do that. And so in order to clean our emissions, which is good for the planet, and to reduce our dependency on fossil fuels, also good for the planet and long-term good for the economy, we have got to do something different. And so electric technology on a vehicle is the only alternative. And how we power that with batteries or fuel cells, that's what we're here to talk about. But both of those accomplish diverting the Titanic from hitting the fossil fuel iceberg. And so that's what we want to do.
Okay, great. All right, battery team, do we have, you have 2 minutes to talk about the same subject. Why make the change from fossil fuel technology to begin with?
Sure. Yeah, no, I think we're obviously in agreement here, all of us, I think, on this panel, at least I hope. But, you know, while it's a clear position by all the scientists that this is something we need to do, it really doesn't take a scientist to know that, you know, fossil fuels have been created over millions and millions of years, and we've basically extracted those and burned and used those within the last 1 to 200 years. So in the US, that means we'll just use 2014, highway vehicles accounted for 22 million tons of carbon monoxide, 4.5 million tons of nitrogen oxides, over 2 million tons of volatile organic compounds, and half a million tons of particulate matter. And so, you know, I run and I bike a lot. I'm in the environment a lot, and I feel the effects of those emissions. I see the impacts of those emissions in our water and in the air. And I know my body in particular our lungs are filters. And so, you know, it's just not a sustainable pathway that we're on, and we have to get away from fossil fuels. And both battery electric buses and fuel cell buses are an immediate need.
Great. Thanks, Jason. So to wrap it up, hydrogen team, is there anything else you want to add? You've got 1 minute to.
Yeah, of course, Dan. Thanks for the introduction, but in the interest of avoiding alternative facts, I graduated from Berkeley in 1976. You just added 20 years to my life. So if we went by that, I would be approaching 100 years of age. So thank you, but no thank you. So I just want to pick up on what Jason and what Karl said, and that is that in terms of direct impacts, we're talking about improving the quality of life for our passengers and our drivers, as well as our technicians and mechanics that are working on battery electric and fuel cell electric buses. They do not have to inhale the toxicity that comes from petroleum-based fuels. So there's a direct benefit that goes right to the core of what we in public transit are there to provide the public and our employees.
Great. Wow. Jaimie, you got it done in time. That's amazing. Good start. Good start. All right. So, well, that's great. That was a nice softball question to start. So let's pick up the pace a little bit here. I'm going to this time start with the battery team. And the question is, if you had to pick one advantage your technology has over your opponent's technology, over hydrogen fuel cell, what would you pick and why?
It's really easy for me. Battery electric buses are twice as efficient as fuel cell buses. With a fuel cell bus, you have to have an extra energy conversion device, which is the fuel cell, to convert hydrogen to electricity. So fuel cells are about 50% efficient if they're controlled correctly. You know, they can sometimes go up to almost 60%, but basically it's a 50% energy debit. And you're adding a fuel cell, you're adding DC-DC converters, you're adding hydrogen storage system and all the plumbing and extra controls. So if a battery electric bus can meet your operational needs, why add all that? Why do that?
Yeah, and just adding to that, Jason, so if you think about the infrastructure, additional infrastructure that you need for fuel cell buses, if we think of the operational cycle of buses running from depots and garages in urban areas, throughout that urban area on a fixed route, there's electricity available throughout the urban area to charge either at the depot or even to charge en route. We don't have to reinvent the wheel here. We don't have to add a whole new layer of infrastructure to run battery electric buses and have those as a reality today in our communities and begin to already reduce those harmful pollutants that I've already mentioned.
All right, great. Hydrogen team, biggest advantage. Well, let's not talk about the biggest advantages. Why don't you rebut them? What do you think your biggest advantage is, or what do you think their biggest disadvantage is? Go ahead, jump in.
Yeah, I'll take that. I'd love to rebut that. So, you know, again, both battery electric and fuel cell electric address zero emissions on the vehicle, and they both address reducing fossil fuel usage on the vehicle. What battery electric struggles with is what fuel cell electric excels with, and that is range. And so as a transit provider in my community, I want to design the service that we provide so that it meets the needs of the community. I don't want to design service that meets the needs of the equipment. And battery electric vehicles do not have the range that diesel buses and fuel cell buses have. And so if I have to buy twice the number of vehicles or 1.5 times the number of vehicles, or I have to design shorter blocks for the vehicles to run on, that then cuts into the efficiency that Jason was talking about, because I'm operationally inefficient then. I might be energy more efficient, but I'm operationally less efficient. And the key thing that Jason said is, if batteries can meet your operational needs, why would you add these extra things? Well, from my perspective, there are a lot of times that the battery electric buses don't meet the operational needs. I will grant that sometimes they do, and if that's the case, go for it. Use battery electric. But if you want to run a transit system that meets your community's needs instead of your equipment needs, fuel cell.
I'd like to just add, Karl, that was a great response. And adding to Karl's point, in the public transit sector, of which I spent 26 years, there are 3 key factors in deploying our resources. One is the bus schedule, the other is the passenger schedule, and the third is the driver schedule. And now with fuel cells, we can keep it to that level of operational efficiency with charging those vehicles. Now we add a fourth dimension and a great deal of more complexity to the process that Karl is trying to avoid.
Great. Okay. Let me. You get battery team. You get 1 minute rebuttal on this, and then we're going to swap the tables here.
Yeah, Jason, I'd like to have a go at this. It's clear that we have some issues here with regard to what electromobility means. Electromobility is a convergence of data and mobility. And in the future, the vehicles won't just run fixed routes. The vehicles will actually respond dynamically to demand in the network. And on that basis, some of the arguments that have been rebutted on the hydrogen side make no sense. Hydrogen, without a doubt, has significant advantages, but if you're running very long distances, but urban buses, even if they run 30, 40 miles, they're not running long distances. So we have to think of the future of transportation and the future of energy here, and not really try to replicate the diesel fueled model, which has failed with an old technology like fuel cell.
Oh my goodness!
Great. Well, we were gonna kind of reverse this question. My idea was to ask it again, but what I'd like to do, I think there's some good points being made here. So let's extend this just a little bit. I know, Jaimie, you're chomping at the bit, so I'm going to give you each, one more chance to just respond to the other before we move on to the next question. So just a minute apiece. Go ahead.
Well, I have to respond that we're not looking at old technology. I've worked in public transit. I know transit. I ride transit. I also ride a bicycle. Fuel cell and battery electric are both advanced technologies, but no matter how those vehicles are scheduled in service, whether they're trunk line routes or feeder routes or demand responsive routes, the same factors still apply in terms of how to allocate resource of labor, of vehicles, and of drivers. So I think to characterize fuel cells as old technology is really missing the point entirely. So I'm sorry, Leah, I respect you from many different perspectives, but I cannot accept that argument at all.
I think the point I'm trying to make is that if you think about fixed schedules, fixed routes, buses running empty with only a few people in them, that's been the model of transit today, and it's the world over. What we're saying is that with a more dynamic, connected system, that some of the significant advantages that Karl talked about for hydrogen cease to become barriers or impediments for electrification. Where it's a more smart, intelligent system, and you can put vehicles on the road that have enough energy to do a particular route to pick up people at certain locations. So that's the point I'm trying to make, and I do think that what you're trying to do with hydrogen is really replicate the existing model, which if we look at the role of ride sharing and autonomous vehicles and a lot of the technologies that are coming down the line, transit's going to be under a lot of pressure for utilizing that road space even. So I think transit's going to have to be smarter in terms of the number of vehicles it runs, the size of the vehicles, and their occupancy. So that's the point I'm making. And that's why I refer to hydrogen, the way it's been presented here, as being a zero-emission alternative to diesel. But when we talk about electromobility, we're not just talking about the fuel source, we're also talking about how it works operationally and actually to the benefit of the riders ultimately, to provide a higher quality, better service and get more people on buses and out of their cars.
I don't disagree with what you said. I will just make the last point that hydrogen and fuel cells give you that flexibility to modify service, which is going to have to change. I don't disagree with you at all, Leah, but I would argue that hydrogen fuel cell gives you the most flexibility to accommodate the changes that transit is having to make. And I'll leave it at that.
Okay, good. Well, I'm going to break you two up, and we're going to get on to the next question. Next question is, we get back to, Karl really liked your point about energy efficiency versus operational efficiency. And if we look at the incumbent technology, diesel primarily, CNG also, they're very operationally efficient in the fact that a diesel bus will go 400 miles on a good day, might still do 360 or 370 on a bad day. So it's a tough technology to compete with, especially since based on its performance is how we kind of operate the systems to begin with. But if you look at diesel and CNG, talk about the biggest advantages your technology have operationally to diesel or CNG and the biggest challenges you have. So we're going to start with the battery team on this one.
Yeah, other than the previously discussed benefits of zero emission, you know, they're obviously quieter, smoother to drive. You know, I think obviously fuel cell vehicles are also electric drive. So you kind of have those benefits as well. Again, it gets back to the efficiency improvements over fuel cells. But you know, I think the changes or the challenges that the hydrogen team previously mentioned in terms of range, and I'll give them even charge time, takes a while. There are plenty of technologies that are coming out to help solve those problems. First, we see a lot of OEMs looking at in other areas of bus systems to increase efficiency. It's either driveline efficiency with e-axles, it's heating and cooling efficiency, to squeeze everything we can out of these buses, which is great, and remove those inefficiencies. But you know, we also see a lot of agencies taking advantage of on-route charging. MARTA, for example, here in Atlanta, actually 100% of their routes connect to their rail stations. At their rail stations, they do have layovers. They have dedicated bays for loading and unloading, and they're excellent places to put either overhead fast charging or wireless charging, high power charging. And that charging will allow those buses to go all day long. Some of those routes or blocks operate 20 hours. And so, you know, we see agencies taking advantage of that. Also, rail stations, for example, have cheaper utility rates. They have traction rates, making the fuel very cheap. In this case, I think the utility rate will be around 5 cents a kilowatt hour, which is equivalent to about 50 cents a gallon of diesel. So it's much cheaper to operate in those conditions. So a lot of urban environments can take advantage of opportunity charging pretty easily where they have the real estate already and access to substations. But, you know, even in urban areas, there's more, I guess it's easier to secure the real estate and land and deploy these types of solutions. And then the last thing is charge management. There's a lot of smart tools, software tools that can be taken advantage of to coordinate buses, coordinate and be able to manage state of charge among a large fleet of buses. And Leah could talk about charge management, how critical that will play in. But it's not just about the buses. It's about all of the supporting technologies that will allow battery electric buses to fulfill all the operational needs of a transit agency.
Okay. All right, Jason. Yep. I have to cut you off for time. Hydrogen fuel cell guys.
Yeah, thanks for teeing that up for me, Jason, because I want to circle back around to operational efficiency because you know, I work at a transit agency. I'm putting the service out on the street, and I can tell you that 75% of the cost of providing our service is in the operator, the person in the seat, not the vehicle, not my salary in the office, not the lights. It's the 75% of operating is personnel. And if I have to have personnel just sitting around the train station waiting for our buses to charge, every 30 miles or so, then I am by default not experiencing operational efficiency. And you talk about fuel cost, we're installing a solar array that we will use to power our hydrogen production. So we essentially will be providing our fuel for our vehicles for the cost of water. And I'll put the cost of water up against the cost of diesel fuel or electricity any day of the week. So yeah, it does come down to operational efficiency. And just as a quick side note to that, it also comes down to resiliency. If there's a power outage, storm rolls through, and all your vehicles are running on, you've got to charge them. You're not putting service out on the street because you can't fuel your vehicles. We can have liquid or gas hydrogen delivered if our production station is down. But also because our production station is on our own solar array, we likely will be able to continue producing the hydrogen if we have a power outage. So yeah, I think it does come down to operational efficiency.
All right, got a 1 minute rebuttal, battery team.
Okay, so I would say an advantage compared to diesel, the electric bus is a much more connected vehicle. So it's also has a lower maintenance profile compared to a diesel bus because there's less moving parts in the vehicle. So the buses are monitored in real time, and that's going to help a lot with maintenance and maintaining uptime. But diesel buses are more expensive to operate and to service and maintain. So from that perspective, the electric bus fleet may not need to have as many spares in the fleet when initial route calculations are being made. And that's going to be a significant advantage over diesel buses. Also, the connectivity will allow for better route planning and knowing where those buses are at any particular point in time and being able to make decisions around the efficiency of the fueling for the buses. So taking advantage of en route charging or returning buses to base, and also factoring in deadhead and how to eliminate the costs associated with that. It's much easier to do where you have visibility of a connected vehicle, and you just don't have that today with diesel buses.
Okay, great. All right, well, Karl mentioned resiliency, and resiliency is certainly an issue. We've got a lot of changing times, and we've got more disasters to deal with. So could you guys talk just real briefly, not just compared to each other, but compared to diesel and CNG, what are your advantages and disadvantages from a resiliency perspective, from power outages on the battery electric side to lack of hydrogen fuel on the hydrogen side, or power outages there as well? But from a resiliency perspective, could you talk about advantages and disadvantages? And I think this time we are going to start, let's see, I started with the battery team last time, so is it hydrogen team this time? Is that right?
Yeah.
Okay, all right, hydrogen, jump in there.
Okay, so here I am from sunny California, trying to avoid, we have Spare the Air Day, the 21st day of smoke pollution. We also always face the issue of turning off the grid system. That's happening as we speak. Earthquakes are always a potential problem that we face. So where are the advantages? Diesel and CNG vehicles can be used and are used here in the Bay Area. Buses, transit buses, are used to move people out of the region to long distances. One of the advantages with fuel cell is that we can replicate that range. If we have to move people from hospitals or senior centers, not just down the road, but out to a completely different area, like to Sacramento or elsewhere where there's available resources to help people. But here's the other advantage. There is, on a 40-foot New Flyer bus, fuel cell bus, there's almost 600 kilowatt hours of stored usable energy. On an articulated bus, over a megawatt hour of usable energy. And CTE has been working with many of our partners, some of our partners, on inverters that would allow those vehicles to plug into a switchgear at a hospital or senior center and run those facilities in an emergency. And what does it take to refuel those vehicles? Minutes, or to switch them out with another vehicle. So that brings a tremendous amount of resiliency capability with hydrogen fuel cell technology.
Oh, that's good. That's good. That's an interesting comment on providing backup power. Jason on our staff has actually been the one that's working on that project. But from a resiliency perspective on the battery side, what are your biggest challenges and what are your biggest advantages?
I think they're the same as fuel cell, really. I think fundamentally they both address resiliency by reducing and eliminating carbon emissions. Jaimie mentioned it, greenhouse gas emissions are directly linked to the warming of the earth and increased global surface temperatures, which lead not only to drought conditions, but also the frequency and intensity of the storms that we see. So, what better way to address resiliency than to reduce or eliminate deadly and destructive storms? But second, Jaimie's right, bus exportable power is certainly critical as what we found in, when we did as we're doing this project for bus exportable power, is that its best utility is to be able to deploy these buses as generators quickly. Most of the generators that are deployed in storms and blackouts at the state and even federal level are just real slow to move. And I was just listening to a great podcast on Katrina, and that was one of the biggest problems is, they just could not, move through the bureaucracy to get things like generators deployed. And when agencies have immediate access to be able to provide these buses for exportable power, it's huge. And yes, fuel cell buses are better because they store more energy and they can be quickly refueled. Electric buses, while you can take them out and use them for a few hours, you have to bring them back and charge them. But they can both be used.
Yeah. Okay. So closing that question, well, either one of you, but hydrogen team, do you guys want to do a close to that question, or battery? Does anybody want to add something for a minute before we wrap this up with the last question? Or we want to move on?
If I can, I just say, a lot of I opened this with talking about trying to move the Titanic to avoid that iceberg, and so fuel cell electric and battery electric, we're partners in moving the Titanic. And when we're talking about resiliency, we really need to change the conversation to resiliency of the planet. And in order to have a resilient planet, we've got to stop burning it up. And our technologies are the path for us to stop doing that. And that is the conversation about resilience. Boy, I'm struggling today. Resilience. I'm not even going to try.
Resiliency. There we go.
Thank you. We all knew what I was trying to say.
I can't do much, but I can say that word. There we go. There we go. Okay. We'll move on. I think this has been fun. We're gonna. What I'd like to do is kind of wrap it up with cost, because I think Karl mentioned at the very beginning, that there's limited amount of fossil fuels. Sometimes we forget. We think only of our generation, and when you start looking 2 or 3 generations out, fossil fuels just at some point will not be there. So, but it does take a lot of cost to make the conversion. But I want you guys to address cost versus diesel or CNG as we move forward. And I want you to address how your technology, which I think right now it's safe to say that capital-wise on the bus itself, that both technologies are still a little bit more expensive than diesel or CNG buses. They are closing that gap, but as we move out through the next 5 or 10 years, how do you see that gap being closed, and what do you see changing both on the diesel side price-wise and on the battery electric or fuel cell side price-wise? So whose turn is it to go first? Is it, I think it's battery's turn to go first. So.
Okay, so I would say that so on the battery side, battery electric bus side, the big mover over the next decade is going to be in the efficiency of the power electronics, in developments around the batteries themselves. And the transit bus segment will be able to harness the savings that are made generally across the OEM spectrum by all vehicle manufacturers, because there's hardly any vehicle manufacturers today, and that even includes things like port handling equipment, forklift trucks, construction equipment that isn't doing OEM that isn't doing some work on batteries and on the power electronics. So as innovation continues apace in that segment, that's going to filter down right across the OEM supplier base, and that will lead to more efficient, lower cost systems. And because battery electric vehicles are going to be ubiquitous, I think they will gain proportionately more in that respect compared to fuel cell, which is already more expensive than battery electric buses. So that's going to be one big driver. Diesel, on the other hand, is obviously it's going to be affected by geopolitical events around the world, and a lot of the remaining significant deposits of oil are in places where it's not that easy either to access the oil. It's very expensive, or there's political instability. So the oil price is going to continue to be vulnerable. And from a cost of energy perspective, in terms of planning, electricity prices are much more stable and will continue to be that way, whereas oil will remain volatile. And as we get to peak oil through the next decade, oil is only going to become more expensive.
Great. Fuel cell guys?
Yeah, I like what Leah said about the power electronics costs coming down. They are definitely coming down on the fuel cell side. You talk to companies like Cummins and Ballard and Nuvera and General Motors, and their targets on cost per kilowatt are somewhere around $100 to $300 per kilowatt. We're seeing great efficiencies in that area, and so I have no doubt the cost of fuel cell buses are going to reach parity with battery electric buses. But I think the biggest challenge for hydrogen fuel cell is the cost of hydrogen. It is not cheap presently. It has a high threshold, but that is being driven down by distributed energy, by solar and wind power sources like Karl mentioned earlier. And the other big factor is supply and demand. I'm happy to say that CTE just helped two large corporations, Shell and Iwatani, successfully receive over $60 million in grant awards to build over 80 light-duty fuel stations. And the value of that, hydrogen fuel stations, and the value of that is it's driving supply and demand, and that demand drives supply, and that drives costs down. So if you look at the DOE targets, we're looking at a potential cost of $3 to $4 per kilogram, and given the fuel cell efficiency, it very easily meets parity with, or will meet parity with diesel and CNG. So it's changing. Right now there's a challenge, but it's changing favorably to cheaper costs in the long run.
And battery folks, you get to wrap this up, and I don't want to steer you too much, but I think the one thing I want you to address is, Jaimie mentioned, as supply and demand, as you create more supply, then cost can come down. Well, I think sometimes when we focus on the cost of fuel cell and battery coming down, we talk about efficiency improvements, but we can also look at supply chain improvements. As you get more and more market share, you get a wider supply chain and costs can come down. And at the same time, as you take market share from diesel, talk a little bit about where you see diesel prices going as their supply chains shrink and their market share shrinks. So I didn't want to tee that up too much, but I do think that's an important point. If Jason or Leah want to take that on.
Yeah, Jason, do you want to have a go with that one? I don't know. I mean,
thanks, Dan. I guess I'm certainly no expert in prognostics for diesel pricing versus quantities. I don't know the answer to that. I'm guessing that it'll go up. I mean, these prices and CNG prices already fluctuate.
Can I make a comment on that?
Sure.
This isn't specific to diesel fuel pricing, but as our two technologies, I'm taking ownership of fuel cell and battery electric here, but as our two technologies start getting a foothold, then the diesel engine market continues to shrink, right? And we already have seen Cummins start to get into the alternative energy motor and engine market. And so they see on the horizon the shrinking diesel fuel market. And at what point will Cummins say, it's not worth it anymore, we're not going to make diesel engines, or they're going to be so expensive that the scale tips the other direction. So we have a fuel cost, but we also have the engine costs and the drivetrain costs. And so everything is starting to shift in our direction. And it's easy for the non-forward thinking transit manager to think, hey, I'm saving my transit agency money. I'm going to stick with diesel. I'm going to stick with CNG, and we're just going to ride this out. Well, you're headed for that iceberg, and you're not going to be able to ride it out. You're leaving a problem for your successors. And so the only way to avoid that iceberg is by taking it on and taking on some of this initial cost. It is more expensive for both of these technologies right now, but that's going to change.
Great. Well, that's, I think that wraps up the questions I have. I think right now, if we have a little bit of time, what we're going to do is try to take some audience questions that either that I didn't ask or as a response to some things that were said. So let's move in and see how much time we have left to take on some audience questions.
That concludes our battery versus fuel cell debate. Thanks to today's panelists for providing an informative and exciting discussion. If you have any questions, don't hesitate to reach out to CTE. We'd be happy to connect you with the right staff person. And of course, thank you to all of our sponsors for this year's ZEB conference, and especially Chris Stoddart with New Flyer for providing today's keynote presentation. Don't forget to join us for the next session happening at 12 p.m. Pacific and 3 p.m. Eastern. The topic is Innovations at Scale, Lessons from the Field. Hope to see you there.